what I want to do now is give you a brief introduction to our Markdown to actually show you at the same time what we can do with a much larger network, or rather, try to convince you that we can deal with a much larger network than the one we saw before, while still retaining sort of computational efficiency. So R Markdown, and so I want to explain this a little bit. R Markdown is essentially the same type of program as Jupyter Notebook. It does the same thing, except that R Markdown natively only works with R. You can use Python in R, so you can use Python in the same way in R Markdown, but the sort of intended language is R. It is Markdown in which you can use R. The thing that makes it, actually, for those of you when you will be writing reports or things like this, the thing that makes it a bit more friendly, let's say, than Jupyter Notebook is that it allows you to embed code chunks the same way we've done before, but it also allows you to embed code within the Markdown itself. So I will show you how this is working. So typically, to create an Markdown, before we proceed any further, the reason why I want to stress the use of Jupyter Notebook is that everybody has the same setup. Whereas here, it might depend on what version of RStudio you're using, what version of R you're using, whatever version of the packages you're using, and that's why I prefer to use our Jupyter Notebook, because at least we're all doing the same thing. But this might appeal to some of you, and if it does, I encourage you to look for more information on this. It's really a cool program. I've used it a lot. So you would create in RStudio an Markdown project by selecting New File and selecting Markdown here. This would give you something like this, where you put a title, you put an author if you want. You can select the default output, but I'll show you slightly later that it's actually very simple to change the type of output that you create. And the nice thing that you can see here is that you can select your output to be HTML, PDF, or Word. So it's a little less interactive than Jupyter Notebook, because the notebook is always there. Here, it's something that's more intended for the creation of documents for distribution. And I'll, like at the end of this brief intro, I'll give you an example of things that I did with this, which is interesting, I think. I don't know if it's interesting, but never mind. So here, this is what I would obtain by default by filling in the info in those boxes that we saw before. I said that the output should be HTML by default. And okay, so this is a file that's created by default when you save this, and it has a little bit of an explanation. So these three back ticks. So this first is the introduction. It can contain more information. This is a language, and I don't know what the official pronunciation is, YAML. It's used in computer applications quite a lot. If you tweak with systems administration under Linux, you'll meet a lot of YAML, for example. That's how they do, in some instances, these network configuration, etc. So this is the intro block. That's where you give global options and so on. And this is a code block. And you see right away that R has distinguished code blocks by giving them a slightly different color. And when we have a code block, it can be either non-evaluated code. It will always show up as code. But what RMarkdown, and that's the same in Markdown, the specificity is that you can have just this thing here that says this is actually our code. Okay. And when you have this, when you compile the document, you will get R, this will be run in R. Okay, so the idea is it's a little different, as I was saying, from Jupyter Notebook, where I have a cell, I evaluate my cell, I have some text, the text is evaluated as well, but what I have is a somewhat continuous document here. The document itself is really produced when you compile. And to compile, it's simple. If RStudio detects that you have a file with extension RMD for R Markdown, then this little thing will show up here that says knit. And knit is compiling your Markdown file. As I said, so this is Markdown, and when you evaluate it, so when you knit it, what's going to happen? Oh, first I need to save it. So example Markdown. And that's a very simple one that I'm taking, okay? And so what it does, and of course it's not appeared, so now I need to select, oh gosh, this. Yes, okay, so it's worked. So this is the output you will get when you've asked to get an output that's PDF. Sorry, that's HTML. So it's created a HTML document where the code appears as these little slightly grayed out boxes. The results appear in these light boxes, and you can embed plots and etc. So I recommend you create a basic document and see what's happening. So let me see if I can now get back to my other RStudio. Oh my gosh, it looks like it's working. Okay, but I am not seeing it. That's okay. Now I have RStudio. So now let's go back to the example we had before. So I have the same thing. This beginning chunk. So by the way, so I should point out. So as I said, a chunk is, well, I'll come back to that. So here, what this is happening, what this is doing. Sorry, it's getting late. It's making what's called a chunk, and that chunk is called setup, and that's often useful. So you see when we run things here, it should come out as Markdown here. You see that it's, you can see at the bottom that the label appears. If you don't put a label, then it's difficult to know, for example, when you have a lot of chunks, which chunk in particular is generating an error. So it's always a good idea to have labels, which I'm going to right away show you how to not do, because I'm not going to have many labels in the code that I'm going to use. But never mind. So this is exactly like, I'll give both Python, the Jupyter Notebook and this code. So you'll have access to both. This is exactly the same thing. The Markdown is the same. So if you want to create a link, you can just put the text here and the link after between parentheses, etc. And you see, so here I'm simply saying this is a R chunk. And it's exactly like we had before. So we had boxes, and here I have boxes, okay, except that they're chunks, etc. So this is working exactly the same way. I will make just a few remarks as we're progressing. One interesting one. So I'm going to run for the first time in a little time. For now, I'll just make a few remarks. So here I am showing you two versions of exactly the same code, okay, except here I've added this, but I have a function. if I run it like this, it will be like I was showing you earlier. It will appear in a little box, slightly gray background box in your HTML or your PDF or whatever. Okay. If you add echo false equals false to your definition of your chunk, then it will not produce any output, code output. So there's several ways, different types of outputs, and if you're interested in learning more about Markdown, this is something you'll run into, because echo equals false is not going to turn off all output, just some of it. But in terms of showing code, it will remove all the code. So when I evaluate the file, what I'm going to see is that this chunk here is not going to be shown. The code in this chunk is not going to be shown. But this is the result, and it's going to be shown. Okay? Because I'm exactly the same way as in Jupyter Notebook. If I want to plot something, I have to show it explicitly, for it to be shown explicitly. So here I'm not changing anything. I think I wanted to show you something, or am I doing it later? Yes, so let me show you one of the beauties of RMarkdown compared to Jupyter Notebook. When I wrote this earlier, I said, well, I wrote it and I said that component has 324 vertices, and so in my Jupyter Notebook code, I wrote 324. Now, this is our Markdown, so what I can do is use a single backtick. That's the thing just below the escape key, okay, on your keyboard. So typically, I don't know on a Mac actually, so I have a backtick and then I go R, and what follows is interpreted as an R command. So if I want to say how many vertices there are, then probably what I want to do is to take the max of C, and what was that? C size. So it has to be a relatively simple R command, because this is not going to be feasible, okay? But that is going to be also evaluated when you run the knit, okay? When you create the file, the HTML from the Markdown file. So provided that function, that variable G $C size is already defined, then you will have access to it within the text. Okay. So besides this, nothing different. This is the example where we got stuck before. And let me just point out that you can evaluate code within code blocks. So there's two ways to evaluate within code blocks. So you can just Control Enter, and that will evaluate just that piece of code block. Okay, this here means that it's running. Okay, and now it's run, and so you have Twitch, which is these 6.8 million variable, well, not variables, edges. And so we'd get exactly the same thing. Another thing that you can do, which is very interesting, so you can just run it like this as well, rather than Control Enter. You can use the little green arrow. But if you're going to run things interactively and you want to check, so here this is the beginning of this example, but suppose I want to check what's happening before, you can also do this, which normally the help will show up. Oh, okay, this is interesting. I see on my monitor that this is not. So when you hover above this thing, it says run all chunks above. So what it will do when you do that is that it's running everything that is before it. And you see here I've created a graph and etc. up to that point. So that means if you need to load variables and you want to use the console to do some debugging here, well, that's typically what you would do. You would load all the chunks above. This way everything is in memory and you can actually try things out. So we've got our Twitch thing. So this is what I wanted to show you. And let me maybe say Twitch 2 here. So I wanted to show you this. Yes, so this is something that's become very popular recently. It has advantages and less advantages sometimes. I have to say that I'm not necessarily entirely keen on it, but it does provide a great list of things. So this is what's called the tidyverse, and it's a set of libraries, not only a single library, and they provide what are called tools for data wrangling, which is essentially manipulating data. We've used one of the libraries of a tidyverse before when we used, I believe, Lubridate very early in the computer examples. Here, I'm using this function here because Lubridate is a very talkative library. So if let me just let me evaluate just this row, and you see this is even so if you do warnings equals false, which is another warning, sorry, equals false, which is another type of communication suppression, and message equals false, you're still going to see all of this appearing in your HTML file. And that's not something typically you want. I mean, so it might be something you want, but suppose you're producing a report for someone, you don't want to do this, okay? You don't want this to appear. And so you can use, and I'll just comment it out, you can use suppress package startup message to make the startup silent. And that's very convenient. It's actually new. It didn't used to exist before, and there were entire pages on Stack Overflow in terms of how do I do to suppress output when I'm loading library X or Y. Okay, so this is, as I said, a very convenient package. It introduces a very different way to think about data, which is actually for us that do a lot of Unix, very natural, and that's the pipe. So the idea, and the pipe takes this form in R. The idea is to use, so when you pipe something, what you're doing is you're sending the output of something into the next function, and you're assuming that that function takes as input this. You can add other parameters, but the main input of the function is what comes out of the pipe. Okay, and the package that provides this is not appearing here. Typically, it's because it's part of tidyr. Okay, it's called Magritte R because this is not a pipe. Okay, for those who know. So what that does, let me explain the syntax here. So I take Twitch, which is my database with variables, the edges, and I throw it through the pipe, and I make it go through filter. Filter is a function that what it does, it's like doing which something satisfies something. And so here what it's doing is it's taking, so numeric ID 1 is the name of the first column in Twitch. And so it's saying only keep those that are greater than 0. And the second is numeric ID 2, which is the second column. And so I'm piping this result again into this, which is now saying only keep those rows where numeric ID 2 is positive. And so in fine, what I get is that Twitch 2 is going to contain Twitch from which I filtered out anything that is 0 in this column and 0 in this column. And if you go on the web, you will see plenty of examples of how people are using this. And so you can see it's running relatively quickly. That's one of the reasons it's popular, is that it's highly optimized. And so you can see I've selected the rows without zeros quite quickly. I should point out that, as I discussed in the previous video, I should, instead of doing this, consider Twitch to be Twitch, to which I am adding 1. And I am not entirely sure, so I'll check with you. Suppose I have a matrix A. I think it's true, but let's say I have 0, 1, 2, and 3, 2 rows. And if I say A plus 1, that normally should add 1 to each entry. Yes, that's good. So if you remember last time, in the last video, I was discussing the fact that the fact that there is a vertex labeled 0 is probably because this is the C convention of starting at 0. And therefore, all I need to do, in fact, to get rid of the zeros is to add 1. Okay. And now remember the previous example I was showing you, I was saying I failed miserably to load the graph, whatever I tried. And now let's see. So it's still running. It is a big graph, and now it's done. So I mean, as a disclaimer, the machine on which I'm doing this has 192 gigs of RAM and 128 processors. So your machine might be a bit smaller, but I've tried it on this little thing here, a little laptop, and it works perfectly as well. So it's not, it might not be quite as quick, but it is not going to kill your kernel or anything like this. And you can see, so I'm not going to go any further in this video, because I will come back to graphs and measures and so on in the next sequence in the course. But again, I'll point out that one of the nice things here is that you can end up doing things like this. It works, and this is an R command. It's going to give me the order of the graph. So it's going to say so many vertices in the graph. And one last comment is I can also say something, is it connected? Yes, it's connected. Well, I mean, yes, it is, but you will see that later. And I can say this, but this will say just true. And so I can be even a bit more constructive in my approach. This is to say the same thing as here, but I want to say it's connected or it is not connected. So I could do something like this. The graph is, and this is still Markdown. So if I use 2 stars and then 2 stars later on, I'm getting bold letters. And I say the graph is, so an R command, but an inline R command. Okay, I've just got one single backtick. And what I'm going to say is I'm going to use this command, which is if else. So that's if then else, but evaluated on a very simple thing and with very simple outcomes. So this says if is connected of G is true, then I'm just going to say, but it could be run a computation, a simple computation or something like this. But here all I'm saying is connected. Okay, I'm making a string that says connected. And if it is not true, if it's false, then I'm going to say not connected. And then I close my call to the R function, and then I close the call to bold function. And so now let me show you how this works. I hope I have no errors. So it's going to take some time. You see, it's telling you what the progress is. Once we hit the loading of Twitch data, of course, it's going to be stuck a little bit. And you see the advantage of saying what the chunks are is to avoid something like this, unnamed chunk 16. And of course, it hasn't changed. So it's produced something. Let me, that's it. So this is the HTML output that I get when I run this. So let me just show you the points that I was illustrating. Remember when I said, well, okay, so you see the code is there, and this is the code for the function that we used to load the file. But remember, I said if you use messages equals false or message equals false, then you suppress the output, the code output. Well, that's what I did. There should be the same box here just below, but I've suppressed it. And then, okay, so it's doing the plots. You can, of course, give more options about what you want, how big you want the plots to be, and so on. I'm just showing you the beginning here. What did I discuss? There was an error here. I don't know why this one didn't run. Must have been a mistake here. That's interesting. Okay, don't know what happened. I will check later, and the code I will give you will run. And this is the second part, which was not running in the Jupyter Notebook. So I am loading the Twitch data. I'm showing you the head of the Twitch data, the size of this, and then I'm doing things. And look here, this is the last thing I was mentioning. It works. There are whatever number of vertices are here. The graph is connected. Yes, that's true. And I've made it appear as the graph is connected, but that's if you throw a non-connected graph in there, you'll get the info that the graph is not connected. And let me come back to R for just a few last comments. Okay, so I said it's quite easy to change what the output is, and the output can be HTML as we just did. So that would be a web page that you can put somewhere or you can distribute to people. The output can, and you can change this by going to this knit button and just going here. And you can see, so the options are knit to PDF and knit to Word. Okay, so let me, for example, knit to PDF. And it's taking, again, a little time because that's when it's loading. So if you run the same thing repeatedly, it might be useful to actually load some of the processing you might do offline and just load the variable. Okay, and now it is outputting. Okay, and I am not seeing it, so let me again. This is annoying. I don't know how to do this like this. Okay, so this is a PDF that was generated by the same call. And so, of course, I mean, if you're making a PDF because you want to write a report for a class or something like this, you would suppress all that stupid output. I'm just putting it there so that you see what's happening. Okay, and we have exactly what we want. And you see that in the PDF, it looks actually quite cleaner. That's it for this part, and I'll just show you an example case of use of this. Okay, I will interrupt the recording for just a few seconds while I'm looking for this because it will take me a while. So as a last example, I'll show you something I was doing at the beginning of the COVID crisis, and that's, I think, a a good illustration of the type of things you can do with RMarkdown that you probably wouldn't be able to do with Jupyter Notebook. And this was a report that I produced with a colleague here at the university, that I produced every day to send, well, mostly every day, to send that to the Public Health Agency of Canada, and that sort of looked at how the epidemic was progressing in the country. And so this whole document, not all of the computations were done in the document. Clearly not, because the computations took about a day to run. But this entire thing is produced in RMarkdown. So you can see, because you can specify what type of text formatting you want, and so we wanted the report to look something like this. You can use LaTeX exactly the same way as you can do so in Jupyter Notebook. You can use, so this I think was just a figure that we included, but okay, you can have some discussion here. We were discussing this, and then afterwards, every day we picked the data and we did some predictions and etc. And all of this you see is that inline calls, as I was saying. So you can see, so they were cumulative, and that number was pulled from the internet, was used and was fitted, and then the figures are produced on the fly and so on. All these fitting results are sort of produced as things go. All of this I will show you probably if we use it again. You can make nice tables and so on. The idea being, okay, so I have, these are my data. So this was the observed data for COVID, in this case it's Alberta, and these were how the different models predicted evolution and so on. Everything like this was produced every day. So as I said, the computations were running offline, but then RMarkdown was used to concatenate all of that. So you could see, you can make the results appear. And so for someone who's producing reports in this context, or any other context where you have somewhat dynamic data, which changes regularly, these things are really convenient. Okay, and that's the last thing I wanted to say about RMarkdown. I mean, a sort of real world use. I don't remember if there were any. I think in this one I didn't do maps. I had another one where I used to do maps. I don't think oh, well, of course we did it for every province. No, I don't think I had maps. In another one, because you can make maps as you go as well. So this is a really sort of quite easy, I should say, easy way. Well, I mean, it takes a long time to make up the shell that's going to be used, but then afterwards you can generate those reports quite easily. And so someone who's maintaining a computer system, for example, can generate reports about the computer system, etc. So this is quite powerful. And that's all I wanted to say about RMarkdown for now. We'll go back to Jupyter Notebook. Not as fancy, but the same for everybody.